Assalamualaikum and good day to Dr. Camelia and Dr. Yoshide Yamada. My name is Muhammad Fakrul Aiman and today I will be presenting my in-depth analysis of analog and digital modulation techniques for the Communication Electronic course. This presentation will cover the fundamental principles, circuit design, and performance comparison between these two modulation domains. Before we dive into the specifics, we must understand why modulation is essential in communication systems. A baseband message signal like human speech has a very low frequency of about 3 kHz. To transmit this signal directly, the required antenna size would theoretically be 25 kilometers. However, through modulation, we map this information onto a high-frequency carrier wave, such as 100 MHz. This allows the antenna size to be drastically reduced to just 0.75 meters, making it practical for modern mobile devices. The first part of my analysis focuses on amplitude modulation or AM. In this technique, the amplitude of the carrier wave is varied in proportion to the message signal's voltage. The most critical parameter here is the modulation index, denoted as M. As seen in figure, we must maintain M between 0 and 1. If M exceeds 1, overmodulation occurs, causing an abrupt phase reversal at the zero crossing point. This leads to envelope flipping, which prevents the receiver from accurately recovering the original message. To implement AM, I analyzed the collector modulator. It utilizes a transistor operating as a Class C amplifier, where the collector supply voltage is modulated by the message signal. For the demodulation process, we use an envelope detector. This circuit is highly efficient and cost-effective as it only requires a single diode for rectification and an RC low-pass filter to remove high-frequency components, leaving only the original message signal for the user. Next is frequency modulation, or FM. Unlike AM, FM keeps the carrier amplitude constant but varies its frequency. The primary advantage of FM is its superior noise immunity. Since most electrical noise exists as amplitude variation, an FM receiver, which only looks for frequency change, can effectively ignore this noise. According to Carlson's rule, FM requires a much wider bandwidth than AM to maintain high-fidelity audio quality. Regarding FM circuitry, I examined the varactor diode modulator. The varactor acts as a voltage control capacitor. As the message voltage changes, the diode's capacitance varies, which directly shifts the resonant frequency of the LC tank circuit. This is a highly effective method for direct FM generation. For the modulation, I propose the phase lock loop PLL due to its ability to accurately track carrier frequency shift even in weak signal conditions. Now, moving into the digital domain, the most basic technique is amplitude shift keying ASK. Specifically in on-off keying, a logic 1 is represented by the presence of a carrier, and 0 by its absence. However, for more robust systems, we use phase shift keying. In binary PSK, bits are represented by 180-degree phase shift. This offers significantly better bit error rate performance because the phase difference between digital symbols is more distinct and easier for the receiver to detect. To meet today's high-speed data demands, we utilize quadrature amplitude modulation or QAM. This technique combines both amplitude and phase modulation. In 16 QAM, we can transmit 4 bits of information in a single symbol. By using two orthogonal carriers in phase and quadrature, we effectively double the data capacity within a limited bandwidth. This is the backbone technology for 4G, 5G, and modern Wi-Fi standards. In summary, digital systems provide much higher spectral efficiency and data integrity, although they require complex hardware such as analog to digital converters and digital signal processors. To conclude, understanding the evolution of modulation from analog to digital is crucial for any communication engineering. While digital technology dominates our modern world, analog principles remain the fundamental bedrock of the field. That concludes my presentation. That's all from me. Thank you.